Okay, John Marsh here. Finishing up homework examples from homework number 7. And so I have problem 13 here for you. This one, like problem 12, is beyond the scope of the sort of thing I'd ask on an exam, but I hope you find this example interesting. If I can get this thing right. So this one says, so what we're going to do is we're going to consider the following identity, which holds for our binomial coefficients. And you can see in the textbook that the notation, it looks like fractions inside of a parentheses, but there's no horizontal bar. So our notation Cn comma k is equivalent to nk, like this, without the bar. Okay? And you can see that clearly in the textbook or in any Wikipedia page. In any case, Cnk times Ckj is equal to Cnj times Cn minus j, k minus j. What does this mean? Well, let's just do the mathematics first and evaluate both the left and the right hand sides using our known definition here, n factorial all over n minus k factorial and k factorial. Okay, I'm just going to plug into this equation. I'm going to plug in the numbers n and k and j, and I'll do it on the left hand side and I'll also do it on the right hand side, and we'll see. It works out. So the left hand side is n choose k. That's how we say it in words. And then k choose j. And I'll just go ahead and write these out. It's n factorial in the numerator. So for the first one, and then n minus k factorial and k factorial. And then I've got kj, which I'll do over here. K in the numerator, the top one, and then k minus j, the top one minus the bottom one, factorial, and then just the bottom one, factorial. Okay? So that's and look, you can see here we have at least one cancellation. K factorial cancels right out. And I'm going to go ahead and rewrite this then with the n factorial in the numerator. And let's see, I have an n minus k factorial in the denominator. I have a k minus j factorial in the denominator, and I also have a j factorial in the denominator. So there's the left-hand side. Now the right-hand side is given as n choose j, and then n minus j choose k minus j. Let's do that. N choose j, and then n minus k and k, no, n minus j and k minus j. And I'm going to simply plug into these equations. The first one's easy, n factorial all over n minus j factorial, the top one minus the bottom one, and then the bottom one factorial by itself. Now this one's a little bit more tricky because I've got the minus j's. I have the one in the top, factorial, and then I have the one in the top minus the one in the bottom. And so I'm going to go ahead and write that as n minus j. Now if I subtract the quantity k minus j, I'll have minus k plus j. And that whole thing factorial. And finally the thing in the denominator, factorial. K minus j factorial. Just to remind you about the algebra there, if I have n minus j minus k minus j, this becomes n minus j minus k plus j, which is n minus k. Okay, so here's what I wrote. This one is the one I wrote there. So we can rewrite this as n factorial all over n minus j factorial, j factorial, n minus j factorial, and this is just n minus k factorial and k minus j factorial. And you can see here that the n minus j factorials cancel, and I'm left with exactly what I have up here for the left-hand side, n factorial in the numerator. And in the denominator, I have a j factorial. I have an n minus k factorial. And I have a k minus j factorial. And you can see that these two are equal. Okay? Now part B says, argue the identity is true by considering three sets, A, B, and C, where A is the largest, and it's of size n, and then B is the next largest of size k, and then C is the smallest of size j. Two ways of choosing elements in these sets yield the two expressions. Well, what we're going to do is we're going to use the product principle, which says that the number of ways of doing something, if we do it in two steps, is equal to the product of those two numbers. So we're going to consider a set. So for part B, consider a set of size n. And what we're going to do is we're first going to choose, I'll just draw a picture on this. We're going to choose a subset of size k out of that. Okay? And that's what n choose k gives us the number of ways of doing that. Now we're going to choose a subset of size j out of those k elements we just chose. So step 1, choose k from n, and then step 2, we're going to choose j from k. And so I'm going to choose a subset of size j out of k, out of those k elements that I chose. So the number of ways of doing that is equal to the product of these two values, which is c n k, and then c k j. Okay? Or in the notation that we're using here, nk times kj. Now I can make that selection a completely different way. What I'm going to do first, I'm going to do the same selection using two different steps. And the first step is going to be to choose the smaller set of j elements out of n. And then I've got to choose the other ones outside of the j here. How many are there outside here? So I'm going to first choose the j elements on the inside, and then how many do I have to choose out here? K minus j of them. So the shaded area has k minus j elements in it. And so what I'm going to do, and the picture will come out looking a little bit different, but you'll see it's the same thing. I'm going to start with my set of n elements, and then I'm going to choose from that a set of size j. And then I'm going to choose out of the remaining n minus j elements a set of size n. I'm going to choose j first, and then how many are left? And then I'm going to choose k minus j out of the remaining elements. So step 1. We're going to choose j elements from n elements. I'm going to make this little circle here. And step 2, I'm going to choose k minus j elements, that is this shaded area here, out of how many? Well, the number that's left for me to choose from, I'm not allowed to choose any of the j elements. So the number that I'm choosing from is n minus j. And when I do that, the number of ways, And you can think of taking this little blob here that I chose in step 2 and just wrapping it around the J like that. Okay? So you can see those are two equivalent things, two different ways of taking two steps to get the same thing. And I'm going to choose J from, I'm going to do step 1, I'm going to choose from N, J, times step 2, I'm going to choose from N minus J elements, I'm going to choose K minus J elements. Or in this notation, N choose J times N minus J, choose K minus J. And so these two are equal due to this argument here. So first I choose K and then I choose J out of them on the left hand side. Here I choose the J elements first and then I choose K minus J elements out of the remaining N minus J elements. And if you want, you can take this blob and wrap it around like that and see that they're the same. So, hope that's an interesting problem. But as I say, something like this is beyond the scope of what I'll put on the exam.